Okay, welcome everybody to my session about SharkSQL, a multi-platform database for OpenVMS, but not only for OpenVMS because it's always called the multi-platform database. As you know, it's running on several platforms, and I want to start with introducing myself. Probably some of you do know me right now. via protocol, and so you can use any interface, any interconnector that speaks, which supports the MySQL MariaDB via protocol, can directly connect to SharkSQL without any without any modifications. That means you can use any MySQL MariaDB driver, ODBC, GDBC, .NET driver, Python, Perl, whatever it is, and also the C interfaces. So now let's talk about usability. Usability is in the first glance was the first, one of the biggest goals of SharkSQL was to reduce the hurdles to use a database. How many of you has ever worked with databases or working on a regular basis with databases? Okay, good. So, and all the I will put me back to the days when I started to work with databases. It was 20 years ago. I avoided to install a database on my own as long as it was possible to do it, let's say this way. Because the first time when I was confronted with a database, and I read about all the theory about database theory, you are confronted with new terms. Nobody knows what is meant with the term. What is a relation? Yeah, relation is a rather simple thing. It comes out of the so-called ER theory, as an entity relationship theory, and this is a mathematical term which says if there entities which have the same number and the same attributes make up a relation. So let's translate it to more common terms. As an entity is a record which has the same number of columns, and all records with the same number of columns is the same data type make up a relation. And what is a relation? A table. So an Excel sheet is a relation. That's easy. That's not that complicated, but you are one of the reasons why it's so confusing that also terms are misleading use. Sometimes in the literature, people talk about a relation, but they do mean relationship. This is something what is something totally different, because it's the relationship between relations, between tables. So this is, there's some kind of confusion about the terms which are used for a database. And this is the first barrier we have to go through, and this is the barrier we have in our head. A database is a complex thing. Yeah, if you develop a database, it's a complex thing, but from the user perspective, it should be rather straightforward, using it like you use any other application. You just install it, you run it, you have to know some basics, for sure. And this should be at least sufficient to install it, to set up, to configure your database. This is the goal from SharkSQL. When we talk about usability, these are the key areas which I'm talking about. Usability means installation procedure. This seems to be trivial, but we come to the configuration, navigation. Data consistency is also a part of usability. We'll come to this. Connectivity. How can I connect different data sources from one point? What I have to do to access data from located on one server and data from another database located on another server. So how complex is programming? How to program? You have a programming language also for private databases, which is called to create your stored procedures. Program is also an issue. Management. This has two areas. One is just the traditional database management, but it's also license managing. It can be also very complex with other databases. And last but not least, usability also affects performance. So, installation process. Whoever has installed whatever database it is, it's always straightforward. You take whatever is the install kit or the setup kit, you click on setup, or you run an install pack, make a packet install if it's Linux, or whatever it is, it's just straightforward. You install it, then you have installed it. And if you then think that you have everything is done, then you are misguided, because sorry for the phrase, but when you have once installed a database, then the shit really hits the fan, because then the end user has to start the post-install procedures. So, and these post-install procedures are how to tell you? All the databases come out with a base setting. And this base setting, it's an odd tradition within the IT industry that all the base settings are so conservative to any manner that if you are using it, and you try to run and configure your database, you will be disappointed about the performance you get out of it. Okay, disappointed will be the understatement of the century. You will say, hey, what's this? So the first thing you have to do in the post-installation processing is to tune your database from the parameter setting of the database. You have to go into the config files or and change all the memory settings and sort buffer settings and all this stuff around. If you're working with a database on a regular basis, that's not a miracle because you know it. But if you don't know it, if you are a new beginner, a new as you want, then Dr. Google becomes your best friend. This is the case. How it works in SharkSQL, you have the installation process, you are asked where to install it, how much global cache you are using, and on OpenVMS, you are asked for the administrator account USC. And the post-installation activities on OpenVMS is just, you have to set the password because during the installation process, there's only a random password is applied to the administrative password. You have to check on your own whether or not the recommended system parameters for a bunch of parameters is set to the OpenVMS systems. And if you are running SharkSQL within a cluster environment, you probably don't have cluster members with the same hardware characteristics. Probably you have a bit more memory on one server than on the other, so you have to adjust it on a server basis. And that's it, nothing more. And when you install it on Windows, you have to do nothing. And you don't have to search, well, there are no entries in Google right now, but you don't have to go through the installation manual because the installation manual of SharkSQL is a two-pager, nothing more. Because SharkSQL inspects your hardware system, and based on the hardware system and on the configuration parameters you have entered during the process, it just optimizes itself so that you can expect just from the installation that whatever you will do, you get the best performance, let's say a very reasonable performance out of it. Well, there will be always some application where you have special requirements, where you should be where some of the system parameters, the database configuration parameters should be changed in some special way. But I guess in 95% it's sufficient to do, you have to do nothing. You do not have to call for a database consultant which tunes your system parameters. It does it on its own. And it's, well, currently everybody talks about artificial intelligence. It has nothing to do with artificial intelligence. It's just rules-based. There's a rule. There's a set of rules in behind how to adjust its internal parameters, and that's it. And when we talk about this is what I call out-of-the-box performance. The database should be out of the box as performant as possible, and we will show you what this means about performance in the next slide. So then one of the next things is about configuration. Well, you have two different sets in the database, how to interact with the database. The so-called DML statements, the database manipulation language. This is an insert, update, delete, and select queries, where you retrieve data, insert data, update data, delete data. Well, this is SQL. It's on its it's a programming language as you want. As RMS, you call system services, you call an SQL statement. There's a descriptive language that says, okay, you tell me in more or less readable form what you want to have to be processed, and you say, okay, this is what I want to have the database to process, and come back with the result when you're finished. And you have the DDL. This is the data definition language, where you define your database, your schemas, your tables, all the database objects that will be around. So, and in SharkSQL, it's the same thing with all other databases, especially the DDL statements are not really standardized. The SQL standard doesn't tell us everything about all the attributes you can apply to the DDL. It just says, if you want to create a database, it's called create database. Or the attributes which you have applied is always vendor specific. So SharkSQL is in the same way as the DDL commanders from Postgres, MariaDB, or something about this. But the vast majority of the attributes doesn't have to be applied. If you create a database in SharkSQL, it's sufficient to say create database and you define the default directory. That's it. And it optimizes itself. There's always a rule-based optimization in behind. You have to do nothing. And just to show you what is the difference, this is what I said, because it's dynamically evaluated in terms of performance. And the other databases you are forced to apply if you want to have reasonable performance. And just to show you, this is an example comparison between Oracle RDP and SharkSQL. These two statements generates at least almost the same performance in terms of read transactions. This is what you have to do in Oracle. You have to do it. And this is what you have to do in SharkSQL. So this is what I say, usability. Basic knowledge should be sufficient to configure your database. If you go to Oracle, you have to know everything about this attributes, the number of cluster nodes. Okay, this is more or less understandable. Then there's cluster nodes and ALs. You have to understand the syntax. You have to know what the attributes are really, what they are meant. What is the effect of all the attributes? SharkSQL, the full statement of it, which internal uses, is also as long as RDB, but it's hidden from the user. You can do it on your own, but you don't have to. The next one is usability, also navigation. Well, if you are familiar with Oracle RDB, or is, from my perspective, is in terms of navigation is pretty well done, because you have the show command. You say show what database object and then database object name. You get the full display of what you have configured, how it looks like. And in SharkSQL, it's similar to Oracle RDB. You say show database. Within the show database, you say which databases are configured, then show the database name. You get all the details and which schemas at the next level of the configuration level, what are available. Then you say show schemas and so on. So you can get top down. Can you navigate into the configuration tree of a database? On MariaDB, forget it. You have the show database and the show schema or the show tables command. You lists all the table names or the schema names or the database names. If you want to have all the attributes about it, you have to ask the information schema. Yeah. If you are used to work with the information schema, you do know all the columns which are configured there. If you are not used to work with it, yeah, it's hard to install. So this is just an example. If you say here show database, you get the list of all the configuration attributes of the database. Then you see which schemas are available, or you have show table account. You see the table definitions. You see what's the column definition, what are the indices, which constraints are in it, and which storage area is located. So you have a full overview of your table configuration. So next thing, data consistency. Since SharkSQL is in a relational database, all relational database must, according to the SQL standard, adhere to the ACID principle. The ACID means atomic, consistency, durability, and isolation. The atomic means just it's transaction oriented. That means everything what has changed within a transaction is an all or nothing principle. And either when you commit your transaction, either everything is written to the database or nothing. So it's easy to understand. Consistency means that at the end of a transaction, the database must be transferred from one consistent state to another consistent state. Database Must always be consistent. Durability means, yeah, nothing more. Everything has to be stored in a persistent storage. And then I'm talking about isolation. Isolation means if you have concurrent transactions, how restrictively data processed by one transaction are isolated from being accessed from another transaction. If you have to keep in mind, if you work you have several processes accessing the same table, probably the same record. Yeah? You have some race condition behind because probably one has already modified it, and you say, okay, I'm not allowing to modify data which I have already read. This is you have to protect it, the access to the data. And there's several levels of the isolation level, which SQL defines as the read uncommitted. That means, yeah, whatever has been written to the database, regardless if it's committed or not committed, another transaction can read it. Well, this is the lowest level of the isolation level, and always causes data corruption. Always will be. Don't know why this had been ever defined as a valid isolation level, but well, it's in the SQL standard. Some databases even do not support read uncommitted. Then there's read committed, which says, okay, I do want to have, if one transaction commits data, I want to have it visible to the other transaction. So if the second transaction reads the data again, it immediately gets the new value of the record or the modified data. Repeatable read means, okay, whatever the transaction updates where the first transaction is running, it must never be visible to this transaction. And serializable means that transactions must be reorganized by the database as if they would be started one after the other. It's not started one after the other, but it's all operating in a way of how it is. And there's also a subgroup which is never mentioned in the SQL standard. This is the so-called strict serialization. There's normal serialization. This is not very important to know what is going out. And this SQL standard also states, this is one of the important things. And regardless which isolation you are using, it is expected that never an update is lost. Well, this statement is a bit confusing, because in the SQL standard also says everything has to apply to the ACID statement, and some people say, okay, this statement just tells you that everything has to be stored on a persistent storage. So if I say it must adhere to the ACID state principle, where durability is one of the major, why do I define it within talking about transactions? Here, from my perspective, it means that if one transaction updates a record, this record must not be overwritten without notification, because this is the so-called lost update phenomenon, and this is one of the major reasons why you have silent data corruption from the application perspective. And this is why I'm talking about usability. So, what is a lost data? A lost update. A lost update is you have two users. Somebody reads a counter. The second transaction also reads the counter, let's say 24. The first one adds 1 to it and said, okay, set counter, okay. And here is the commit time of the first one. Now it's 32. Since we have read the data here before, now we add 2. The result is not 44 like it should be, it's 43. And this is so-called lost update. So if you're running if you are running a bank application and you do your account management within the database and you have have a lost update, then you have the probability that you have two transactions. One is adding to your adding, let's say, $100 to your account. The other one is adding $300 to your account. Well, the first one reads, you have a first value of 100. So here you add 100, so the result would be 200, and the second one would add 50. So the overall result should be 250. But if you have a lost update phenomenon, you end up with 150. This is totally wrong. And this is one of the key reasons why you may get a silent data corruption from the application perspective within an application. I've seen so many applications in the field where I was really wondering what they have done in their application. They're using read committed isolation layer because it's the fastest one. Because with read committed, you do not have to do many checks within the database. You minimize the locking. You get the most out of it from caching and so on. So this is the fastest way to modify data. And then you have an application which just modifies data, makes a commit, and the next statement is a select which reads back the data. And I was always wondering why. The reason why is because they always want to be sure that it's really the real value is in there. Because neither Oracle, not Oracle RDB, nor SQL, no Postgres, no MariaDB supports lost update protection on read committed. SharkSQL provides lost update protection on all levels, all isolation levels. This is if you're not aware, if you're aware of this and you if you handle it from your application, it's fine. But if you're not aware, I'm talking about you start to work with the database. And when you start to work with the database, you are not really familiar or not aware of this problem. You will end up in a corrupted database. Simple as I said, in SharkSQL is on all isolation levels, the loss protection phenomena is is safe against lost update protection. So this is why I also have listed it in the usability. Connectivity is the next thing. If you have who is working with Postgres? Okay, yeah, okay. Postgres is rather simple to connect. You say this is a server, you want to access this database with your credentials, username, password, and that's it. Yeah. So what and when you have this, if you want to access through one server a database located on another server, then it becomes a bit complicated on PostgreSQL. This is but not only true for PostgreSQL, it's also for Oracle RDB, whatever database you have. But I'm concentrating here as an example for PostgreSQL. So SharkSQL is a bit different from all other databases. All other databases have a client-server relationship. You have a client, you have a server. SharkSQL, this is a distributed database engine. So parts of the overall engine runs on the client side, but also on the server side. You can connect to any database located worldwide as long as you have IP accessibility to the server as you want. If you have know a database user and a password, so a database credential, you can log in. That's it. You have nothing to do. And from the client perspective, you do not have to care about where the database is located. Every database seems from the programming perspective as if it would be local. All the complexity, all the ways, the connections between the servers and the relations between the servers, it's all hidden from you. And just to tell you, this is one of the if you're using, for instance, PostgreSQL, if you want to just use a simple SQL statement, then you have to use the foreign data ref. You probably know this. You have here one server, let's call it Omega, and two Alpha 1 and Alpha 2, different databases located on Alpha 2, Alpha 3, and you want to use Omega as the access server to access the data from Alpha. Then you have to perform configuration of Omega. You say, okay, which data server should be integrated to this? You have to define a user mapping. It defines when you come in and want to access the database on Alpha 1, which database user should be used for accessing the data. And this is from the security perspective a bit insecure, because you have to know, you have to guarantee on this side that you can access all the data which are within the database located on Alpha 1 or Alpha 2. So you use a high privileged user to access it. And then you connect from your client to Omega with an unprivileged user. And then you have privileged access to the remote side. This is a piggyback security hole. But however, it doesn't just ignore the security aspect. How many steps you have to do to be able to access Alpha 1 and Alpha 2? And you have to stress this, the DBA manager to do it, because you typically do not have the rights to do it. So then you can execute the SQL statement. There's an alternative way. You can use the DB link, but then the SQL statement becomes a bit strange. You have to know the syntax about this. Yeah, well, let's talk about how it's in SharkSQL. SharkSQL, you do not have to do much. You have alpha, omega, you can ignore omega, you can directly access it. You just say connect to databases sales on alpha arms with the credentials. 1, 2, you run your statement. You do not have to know, you do not have to ask the database manager to configure anything. If you want to go through omega, let's say you have your client in Austria and your servers in the US, it makes no sense to have a direct connection to all the databases. The best way is to go to an access server on the remote side. If you go access, you say set default connection omega, and omega, there has to be an IP address in behind. And then you say connect, and you run your statement. You don't need a database administrator on the remote side to configure anything. So it's you who decides which data you want to access. And as long, and there's also one advantage. If you say connect to the user and password you apply, the credentials, must be configured on Alpha 1 and Alpha 2. And you get all the rights configured on this side. No piggyback acts, no security issues. So, and however, no configuration. So you can decide on your own which is more easier to do. Programming. Programming is, from my perspective, also a part of usability. The SQL standard, there is the so-called SQL PSM, the persistent storage module. Oh, this is the programming language. There are some reasons why you configure stored procedures. This is just a bunch of SQL statements which will be executed when you just call this function. This makes some sense because it's easier to, if there is a bunch of SQL statements you repeatedly call, you should not call it always from the client, and you create a stored procedures and call the stored procedures. That's it. So the big issue with SQL PSM is that almost nobody, probably PostgreSQL and also Oracle RDB, but all others, well, just use some kind of SQL PSM implementation. Oracle, PLSQL. It's almost PSM, but it's not really PSM. So, and when I've looked at it, so I don't know if in the end of the 80s or beginning of the 90s, ADA was a very popular programming language, but I guess it was not. But looking at it, what it is now, who knows ADA? This PSM is totally implemented on ADA syntax. Who knows ADA? ADA syntax? Okay. But do you guess that younger people do know ADA? I don't know. So this was a programmatic decision that I do not implement PSSQL on ADA syntax. I've implemented the programming language, which is what is called CSQL. The difference is C standard. This is C calling standard. C sharp. Everybody which comes out of the university knows C and C sharp. You have no learning curve. You have no training effort. If you know C and C sharp, you can use CSQL. The only thing you have to consider that this SQL statement is considered as a function call. C. That's it. And what is also a problem with SQL PSM, it is just kind of ADA implementation. It's not really ADA because you have a lake of error handling, a lake of exception handling, and so that's why you're using PSSQL only just for short function call, short function. You never ever put into a stored procedure business logic. CSQL supports C like the C standard, without few exceptions. And you can implement business logic inside. You can implement the whole business logic of a whole application without any external thing. I've done it with a lottery business just for testing. This is about a code base, about 5,000 code lines. It's all in the database. You have access points to different functions. You call it from outside, and that's it. Nothing else to do. And if you call it a store procedure, it's always faster than calling it from your application, because it is embedded into the database. It's faster at least. So this is what you can implement is what I call database microservices. Not just only a bunch of SQL standard queries or inserts, but to implement business logic. You can define your own data structure. You can define your own objects if you want. You have a module programming inside. You can define different modules. You can cross references as you do C programming, with all the include statements and pragma statements and all what is around. And what is the reason for database microservice? Performance, or at least performance. Because I've done this with a lottery demo system, online system, and I'm running it on a RX 2800 4 processors, 60 cores, 27 gigabyte of memory, and an AVA 4100. And this demo system has a performance that has 10 to 20 times more can process 10 to 20 times more tickets than any of the European online transaction system of any European lottery system. Just one small server. Okay. So last but not least, a few minutes to go. When you work with other databases, you always have to manage your database in itself. You have to manage your backups. You have to startups, shut down, import, export files, and in many cases you have a bunch of utilities grouped around your database. And I'm not a big fan of it, because this also means Dr. Google is asked which utilities work for what. Here's everything integrated into the CLI. If you want to start a backup, you just say backup database. That's it, database name, and it does it. If you want to restore the database, you say restore database. And implicitly, database management utility comes with the SharkSQL database. So to make everything as simple as possible, after image journal management, process management, data migration management, deadlock detection and management, everything can go through the CLI. You don't have to use any other utility but the CLI. That's it. So, one of the big advantages is that you have a single point of management. You can accept the startup and shutdown of the environment on a particular server and to drop database. These are the two exceptions which you cannot do from a remote. If you log, but you can sit wherever it will be on the world. You connect the database. If you have administrative and you have your username. User has administrative permissions. You can do everything what is listed in here. Single point of management. Yeah. So, and management also is licensing and support. And that now I come to a thing. Commercial databases like Oracle have a complex licensing structure. Sometimes you have to so-called certified licensed management consultants. So you have to choose the right option for you, that everything is properly licensed. And yeah, the price is typically rather high. Then you have to choose for open database services, free for use. It's on risk to use it, at least. Support is typically provided through a third-party company, and some of the employees are more or less involved in the development of the databases, and hopefully in the core development team and not in the documentation management team. But you cannot be sure what it really is. Support costs are typically rather easy. What will be the model for SharkSQL? It will be distributed as shareware, not open source. The rights will remain always, but the development is to be free for download and use. You do not have, nobody is charged for licensing. You can download it as often as you want. You can install it on a server as often as you want on your own risk. You can buy software support. You get it directly from the engineering team. This is a bit of difference to open source, because open source, the engineers doesn't provide support. And the support offerings are just current plans. This is just moving target. Yeah, will be break and fix service and also professional services partners, probably BSI, for configuration consulting, migration consulting, and all the training, offsite, on-site support also. So the basic message is no licensing fees, only support. And yeah, professional services. So now, this is just an appetizer. We talk about PE bench. This is this traditional benchmark utility from Postgres. I've used it to challenge to benchmark different databases because it's really simple to implement on all databases, and it's, from my perspective, the ultimate killer application, because here you have the issue that you have thousands of race conditions. Because you have 3 tables, one with 15 records, one with 500, one with 5 million records. And what you do here is you just update always the same story. And this random just means, random means, it's a semi-random generator. So if you start with 60 processes in parallel, you go to the same series of random numbers through it. So they all access the same data. You have so many conflicts in there, and this is in terms of concurrencies, the ultimate killer application. So sorry, wrong one. So I will go through and this is yet out of the box performance, not really out of the box. In Postgres and MariaDB, I had to adjust some memory settings, but and this is the result. Blue is SharkSQL, red is MariaDB, green is Oracle RDB, and this is this has never been released, Postgres on OpenVMS, out of the box. This is on Windows, the same. You see here, PostgreSQL is here much better. SharkSQL still outperforms PostgreSQL out of the box performance. What we have to consider that PostgreSQL, the default isolation level is read committed, and you have thousands of lost update phenomena. You have to increase the isolation level to repeatable read, and when you see it, if you're using repeatable read, it drops. In SharkSQL, you do not lose any updates. So this is read performance, because you can only just test the read performance, random read performance. Yeah. So that's it. So where we are now on OpenVMS, any platform is supported starting from Itanium. We will also support on Alpha, the latest version 8.4, Itanium x86, and on Windows currently 10, 11, and starting from Server 2016 upwards. So the current status is we are in the alpha testing phase. SharkSQL website has the whole ecosystem to distribute the software is just under constructions. And yeah, it is planned that by end of summer, the alpha testing phase and the ecosystem will be available. So I guess right before the bootcamp, I guess in October in Boston, then we will launch SharkSQL and make it public available. So if you would be interested in an extended field test, just send me an email. And yeah, once the ecosystem is available, you can access the kits and also some blogs which will be available on the SharkSQL.com. So thank you for your attention, and if you have any questions. Yeah.
Do you have a roadmap for Linux?
The Linux port will start immediately after the first the SharkSQL kits will be publicly available for the extended field test. Then we start with the Linux port. But first, we are concentrated to distribute it. OpenVMS is the primary development platform. And first of all, the kits on OpenVMS will be released for extended field test, then for Windows a few weeks later. And when this is out, then we start with the port to Linux. Yeah.
Two questions. The first was when you mentioned your distributed query. You said set connection or set default server, and then you did your select. Is that part of the select statement where every time you run that, you have to do that? Or is that
no?
You set up your server at one time?
Yeah, you said default connection, set connection, that's it.
Right.
It's not part of the SQL statement. It's just you have to inform SharkSQL what will be the direction from where to get the data. That's all.
That makes sense.
Yeah.
And the second one was you talked about CSQL as your language of choice for storage.
Yeah.
Are there any other implementation of CSQL, or is yours the only?
This is the very special implementation that I have on the roadmap. When we go back, you will see that I plan to support SQL PSM in the future, but currently it's CSQL. The big advantage of CSQL, but this goes too much into the details. If you have PSM PSM is part of whatever the database is. Here's a bit different. CSQL is the programming language definition, and SQL is embedded into the programming language. So the database is part of the overall programming definition. You can run it on your own. One of the big advantages is whenever when you develop something, if you have embedded SQL, for instance, if you're embedded in a C program or in a Pascal program or whatever it is. So at least you using a special syntax, and what you can do is you have the CLI. Every command, and every statement you are using with embedded SQL can be also used in CLI. You can step by step go through it as it works. Then you could copy it out to a file, and then you can run it via the CSQL virtual machine. And if this also runs, you can embed it directly to Sui. So you can be sure that it works. This part of the program. So from rapid program development, you can go through this much easier than from other embedded SQL statements, because just look at the declare statement, describe statement. If you describe when you want to get which columns are selected when you're using dynamic SQL, that describe statement is not available on the CLI and other interfaces. Here it is available. So you can first of all, you get to the CLI, type in whatever you want, say, okay, it works, fine. Then you can put it in a CSQL statement. You can say CVR, this is C virtual machine run, and you can execute it and see whether or not you get all the things that you want to have, then embed it into your program. Okay.
The data migration utilities, do you plan to migrate from other databases to SharkSQL?
Yep. The easiest way is MySQL MariaDB. This is already implemented. You make a backup from your from it, and SharkSQL is capable to read the backup files, which is more or less than the text file. You import it. That's it.
Would that include RMS files?
RMS files will be one of the development. Sorry. Yeah. RMS file mapping. So if you RMS file, at least are always binary files. It's binary records. So from a database perspective, this is a large objects, at least binary stream files. What will happen if you just map an RMS? You define a virtual large object which reference to a record, and this will be done automatically by when you define a. So this is the plan right now. You define a large object which references record within your RMS file, and you get it back. This is like you get from an RMS file. And if you write, it's also read and write. If you write it, make an insert. But this will be hidden from View is just a configuration method. You say large object is a static large object which reference an RMS file.
So the idea would be to directly access the RMS files from the statement.
From my perspective, the real idea is if you have an application which just writes records, you should not write it also from the database, because this is a bit an issue from the synchronization perspective. But you should be able to read it, and if you read it through a database, yeah, you open to any utilities, you have to display it on your own, and you can over time, since it is a relative file, you have also records. Okay, this is a record definition in terms of a relation, except that you have to name your columns to find it. You can do it here. So it's just an overlay to that, and then it's like now it's not copying, just directly accessing. But I would not recommend it to access it from both sides, from the RMS side and from the database side. Just write from one side, read from the other, or from both. But this is the plan to do it, because it's always, I've seen, have been involved in so many projects where they have tried to migrate it with a big bang, all RMS files they are using, production RMS files into the database. This is not a good approach. Do it step by step if you really want to do it. The first thing is mapping. Yes, okay. So.
Yeah.
Okay, thank you.